So there are many tests to test the convergence of the series. Already in the last lecture, we study the comparison test 1, comparison test 2, and a limit form of comparison test, and solve some examples. So now we study here the Cauchy's test. So what is the theorem? If summation un is a positive term series such that limit of un raised to 1 upon n as n tends to infinity is equal to L, then the series converges if L is less than 1. So this L is less than 1, then the series is converges. If L is greater than 1, then the series is diverges. And the test get fails if L is equal to 1. If L is equal to 1, then test get fails. So this is the Cauchy's test. So we now take the example that is the test the convergence of the series. So summation 1 upon root n raised to minus n raised to 3 by 2. So we solve this series by using Cauchy's test here. So what is here? Un is equal to, so nth term of this series is 1 plus 1 upon root n raised to minus n raised to 3 by 2. Okay, so this is a very simple one. So then what is the limit? So we find out first limit. Limit is n tends to infinity, un raised to 1 upon n. So that is limit is n tends to infinity. What is the un? Un is this. So this is 1 plus 1 upon root n raised to minus n raised to 3 by 2 raised to this 1 upon n. Okay? Therefore, limit of the n tends to infinity, 1 plus 1 upon root n. So what is this? So what happened here? So n minus n raised to 3 by 2, and this raised to 1 upon n. Then what is this? So this is n raised to minus 1. So then 3 by 2 minus 1. So this is 3 by 2. So this is 3 by 2, n raised to 3 by 2 into n raised to minus 1. So then what happened here? So n raised to 3 by 2 minus 1. So this is n raised to 1 half. So that is the root n here. That is the root n. Okay. So this is very simple. Then this becomes here root n minus root n. Okay, minus root n. So therefore, this can be written as limit n tends to infinity. So this is 1 upon 1 plus 1 upon root n. So this is plus root n. Plus root n. Okay. But we know the standard limit. So that is, what is the standard limit? 1 plus limit as n tends to infinity. N tends to infinity. 1 plus 1 upon n raised to n is equal to e. Is equal to e. So what is the limit of this? So limit of this is 1 upon e. But e is what? So e is greater than 2, less than 3. So the value of e lies between 2 and 3. 2 and 3. So this is certainly clearly less than 1 upon e is less than, strictly less than 1. So what is L? So L is what? L is the limit of this. So this is L here. This is L. So here L is less than 1. L less than 1. Then by Cauchy's, test. Then by Cauchy's test, the given series so what happen if L is less than 1, then the series is convergent. Then by Cauchy's test, the given series is convergent. Series is convergent. So this is a very simple example. Okay, so taking limit of un raised to 1 upon n as n tends to infinity, so un raised to this raised to 1 by n and so on, we get limit, so that is less than 1 upon e, and this is less than 1, and if L less than 1, then the series is convergent by using Cauchy's test. Yeah, okay. So what is the next example? Test the convergence of the series here. So another example, very simple example. So summation 2 raised to n e raised to minus n. So this is a series here. So test the convergence of that series. Solution. So here n, the term of that series is 2 raised to n e raised to minus n. E raised to minus n. So what happened? So limit as n tends to infinity, un raised to 1 upon n. What is un? Un is 2 raised to n e raised to minus n raised to 1 upon n. Okay, so this is what? So this is equal to limit as n tends to infinity. So n get cancelled, n get cancelled, so that is a 2 e raised to minus 1. Okay, so this is the limit as n tends to infinity. So that is 2 upon e. So that is limit is a 2 upon e. So this is L. So this is L. So what happened? E lies between 2 and 3. E lies between 2 and 3. So E is greater than 2 and less than 3. So denominator is greater than 2. Therefore, what happened? So this is less than 1 clearly. So therefore, by L is less than 1. L is less than 1. So first condition is here. Yeah, L is less than 1. Then by Cauchy's test, the given series is convergent. Given series is convergent. Okay, so this is a very simple example. So we solve many examples by using the Rabbit's test. So what is the next test? So that is the D'Alembert's ratio test. D'Alembert's ratio test. So what is the D'Alembert ratio test? So same statement. So if un is a positive series such that, so we take here limit of un divided by un plus 1 is L. So that is a finite. L is un upon un plus 1. So that is limit that n tends to infinity is L. Then the series 1 converges if L is greater than 1, diverges if L is less than 1, and the test fails. So this test, D'Alembert's ratio test fails if L is equal to 1. So what is the, again, repeat here the D'Alembert ratio test. If un is a positive term series such that limit of un upon un plus 1 is equal to L, then the series converges if L greater than 1, diverges if L less than 1, and test get fails if L is equal to 1 here. So taking an example, very simple examples here. So test the convergence of the series here. So take an example. Summation n square divided by 3 raised to n. Okay. So this is a series. Test the convergence of the series. Solution. Here un is equal to n square upon 3 raised to n. What is un plus 1? Put n is equal to n plus 1. So this is n plus 1 bracket square raised to 3 raised to n plus 1. Put n is equal to n plus 1. N is equal to n plus 1. So then un upon un plus 1. Un upon un plus 1. So that is n square, un is this, n square upon 3 raised to n divided by un plus 1 is this. So n plus 1 bracket square divided by 3 raised to n plus 1. So this can be written as n square divided by 3 raised to n multiply by 3 raised to n plus 1 divided by n plus 1 bracket square. N plus 1 bracket square. So what happened here? So this equal to, so this is 3 raised to n plus 1. So dividing 3 raised to n plus 1 by 3 raised to n. So remaining 3 only. So this get cancelled, we get 3. Dividing by 3 raised to n plus 1 by 3 raised to n. So 3 only there. Divided by, so divided by n square to numerator and n square to denominator also. So this is 1 plus 1 upon n bracket square. Okay. So this is un upon un plus 1 is 3 upon 1 plus 1 upon n bracket square. So therefore limit as n tends to infinity, un upon un plus 1 is equal to, limit as n tends to infinity, 3 upon 1 plus 1 upon n bracket square. So what is the limit of this? So limit as n tends to infinity, 1 upon n tends to 0. So that is 3 upon 1 plus 0. So that is 3 here. So this is L. So this L is here. So then what is the convergence of that series by D'Alembert's ratio test? So that is, since L is equal to, what happened? L is equal to 3. L is equal to 3. So this is greater than 1. Then what happened? Then the given series, then by D'Alembert, then therefore the given series is convergent. Series is convergent. Okay, by D'Alembert's ratio test here. So this is the very simple examples. We take another example. So test the convergence. Test the convergence of the series x plus x square by 2 plus x cube by 3 plus and so on, x raised to n by n plus and so on infinity. Okay, test the convergence of that series. Yes. Solution. Here, what is the un? So un is equal to x raised to n divided by n. So what is the un plus 1? Put n is equal to n plus 1. So then what happened? So x raised to n plus 1. divided by n plus 1. Okay, so that is simple. So that therefore limit of un upon un plus 1 is equal to limit as n tends to infinity. What is un? Un is x raised to n divided by un plus 1 is what? X raised to n plus 1 divided by n plus 1. So what happened here? So this is equal to limit as n tends to infinity x raised to n divided by n into n plus 1 divided by x raised to n plus 1. Okay, so this equal to limit as n tends to infinity. Okay, so dividing by n to this factor, divided by n to this, so what happened? 1, n divided by n, 1 plus 1 upon n. Okay, so divided by x raised to n to numerator and denominator. So this here cancel. So dividing this 2 by x raised to n, so that is 1 upon x here. So how to find that limits? Because the limits depend on x here. Okay. So what is the limit of this? Limit as n tends to infinity. So 1 upon n tends to 0. So this is 1 plus 0 into 1 upon x. So this is 1 upon x. So the limit of un upon un plus 1 depends on the value of x here. So what is the convergence? Hence, summation, that is series here. What? Which series? This series. So that is x raised to n upon n is a convergent. Is a convergent if, so that is L is equal to 1 upon x. L is equal to 1 upon x is greater than 1. Is greater than 1. So here test 1. So that is in test. So what is the first condition? Converges if L greater than 1. If L greater than 1. So that what it imply? So multiplying x throughout. So we get here. So that is x is less than 1. X is less than 1. If the value of x is less than 1 in this series, then the series is convergent. So the convergence of that series depends on the value of x. If the series x raised to n divided by n is divergent, if L is equal to 1 upon x is less than 1, L is equal to 1 upon x, so divergent if L is less than 1, so this is less than 1, so this implies that what? So that is x is greater than 1. So if x is greater than 1, then this series, if x is greater than 1, then the series is divergent. Then what happens if, but when x is equal to 1, therefore the given series is equal to summation un, something x raised to n divided by n is equal to, put x is equal to 1 in this series, put x is equal to 1, so 1 plus 1 half plus 1/3 plus 1 by 4 plus and so on. But this series is a harmonic series, so that is summation 1 upon n here. So this series is a harmonic series, and how do we prove that? So this series is a divergent series. So which is a divergent series. So limit of this is infinity. So this is a divergent series. Okay. So that is a very simple one. Okay. So we learn here the Cauchy's root test. What is the Cauchy's root test? And taking 2 examples. And now this is the D'Alembert ratio test and taking 2 examples. So what is the next test here? So that is a Rabi's test. So what is the rabbit test? So there are many tests to test the convergence of the series. So if L is equal to 1, then test get fails. Then there are new tests such as Rabbit's test, D'Alembert ratio test, and so on. So now Rabbit's test. So what is the Rabbit test? Theorem. Let summation of un be a positive term series, and let limit as n tends to infinity, limit n into, so un divided by un plus 1 minus 1 is equal to L. So then 1 if L is less than 1, then the given this series is convergent. 2 if L is greater than 1, then summation un, so that series is divergent. And if just a minute, so correct here. So if L is greater than 1, then the given series is convergent, and if L is less than 1, small correction. So if L is less than 1, then the series is divergent. And third, test fails if L is equal to 1 here. Okay. So this is the Rabbit test. So what is the Rabbit test? Let un be a positive term series, and let limit of n into bracket un upon un plus 1 minus 1 is equal to L. So that is L is finite. Then if L is greater than 1, then the series is convergent. If L is less than 1, then the series is divergent, and test get fails if L is equal to 1 here. Okay, we take example. Test the convergence of convergence of 2 upon 7 plus 2 into 5 divided by 7 into 10 plus 2 5 into 8, 2 into 5 into 8 divided by 7 into 10 into 13 plus and so on. So this is a series here. So what is the solution? Let here, what is un? Un is the nth term of that series. So this is the first term, this is second, third. So what is the nth term? So nth term is what? 2 into 5 into 8 and so on, 3n plus 1 divided by 7 into 10 into 13 and so on, 3n plus 4. 3n plus 4 here. Okay. So if you put n is equal to 1, then we get first term, 2, second term, 3, n term. So this is the nth term of the series here. So what is un plus 1? Similarly, put n is equal to n plus 1, then you get n plus 1th term. So that is 2 into 5 into 8. So into 3n plus 1. So what is this is nth term in this term here. So what is the next? So that is 3n minus 2 divided by 7 into 10 into 13 and so on, 3n plus 4. So that is, what is the next term here? 3n plus 7. Okay. So this is un and this is un plus 1. So what is the limit? Limit of n tends to infinity of un. First we find un upon un plus 1. So this is what? Limit as n tends to infinity. So what happens? This divided by this. So this divided by this. So we get 3n plus 7 divided by 3n plus 2. So this is the limit as n tends to infinity. Dividing to numerator by n and dividing to denominator by n. So that is what happens, 1 plus 7 by n. So that is 3 plus 7 by n, and this is 3 plus 2 by n. So limit is 1 here. 3 by 3. So limit is 1 here. So what happened by D'Alembert ratio test? If this is L. This is L. If you remember what is D'Alembert test, so previous test. If L is equal to 1 in D'Alembert ratio test, then test get fails. Therefore we know that. So that is D'Alembert ratio test. The test get fails. Test fails. Test fails. Okay. So now we apply Rabi's test here. So now we apply Rabi's test. So that is, what is the limit? So limit as n tends to infinity. N into bracket un upon un plus 1 minus 1. Okay, so this is the limit as n tends to infinity. N into bracket. So what is un upon un plus 1? Un upon un plus 1 is this. 3n plus 7 divided by 3n plus 2. So this is 7 and minus 1. Minus 1. So what happened? So this is limit as n tends to infinity. Okay. So that is taking LCM 3n plus 2. 3n get cancelled. 7 minus 2, that is 5un into bracket. 5 upon 3n plus 2. Okay. 3n plus 2. So again, dividing to numerator by n and denominator by n. So what happened here? So limit will be 5 by 3. 5 by 3. So this is L. So this is greater than 1. So this is greater than. So L is equal to what? L is equal to 5 by 3. 5 by 3 greater than 1. Then what happened? If L greater than 1. So L greater than 1. Therefore, then the given series, this series is convergent. Okay. So these are the very simple examples we have taken here. The 3 tests. So D'Alembert ratio test, Rabi's test, and Cauchy's test. So you remember, it is necessary to remember the statement of those tests. So minute corrections are there. So just you remember carefully those tests. Then you can solve the examples easily. So thank you.